Hello, Spartan fans. 6.6 phase shifts. Here we go. Lots of new letters going to be introduced. The generic form of a sine or a cosine curve with shifts is known as A, which stands for the amplitude, sine or cosine, omega x minus phi plus b. The W, what looks like a W, is omega. And what looks like a zero with a line through it, which does not mean no solution, it means empty set, but now means phi. Phi, not phi. It's phi. Can't believe I missaid that. It's phi. Okay, this is a lot of Greek. Your book uses these variables, and I will be consistent and use the same variables. However, you are much more likely to see it written as a sine quantity bx minus c plus d. These are equivalent. What you have to be careful of is in the Greek equation, b represents the vertical shift, and in the non-Greek equation, I guess I'll call it, b represents the coefficient on x. So I'm going to be consistent and use the top equation. Your calculator uses the second equation. So when we do curves of best fit, you will see A, B, C, and D. Okay, so, oh, and by the way, this can all be found on page 423 of your book. Here we go. Period is 2 pi over omega. Omega, the coefficient on x. So the period is 2 pi over omega. And where you start this graph is at phi divided by omega. That looks very confusing, but you've been doing this quite a bit already. It's going to determine what we call the phase shift. And the phase shift is how much you're moving right or left. So we've been calling it a horizontal shift, and for whatever reason in trig functions, it is called the phase shift. So, I'll ask you all the time, what value of x makes this 0? And what will we do? We'll set, in this case, omega x minus phi equal to 0. Well, what happens when you do that? When you're trying to solve for x, you get, let me move it this way, omega x equals phi, divide by omega, and you get phi over omega. And that is the equivalent of your phase shift. Right, left. It used to be called horizontal, now it's called phase. How do you determine the intervals? So we've kind of talked about this before. You take the period, which is 2 pi over omega, which is fancy for the period. And remember, the period is the length of a wave, the length of a cycle. The period is 2 pi over omega. And the intervals, excuse me, you divide by 4. Why 4? Because there are 4 quadrants in the unit circle. And B is the vertical shift and creates what we call the sinusoidal axis. Sinusoidal. Again, this can all be found on page 423 of your book. Okay, so we are going to do a funky graph that includes all of the phase shifts and intervals, starting points, endpoints, etc. So let's graph y equals -3 times the cosine of 2x plus pi over 3 minus 4. And I'll ask you to evaluate all the important, pertinent information. What's the phase shift? What's the vertical shift? What's the sinusoidal axis? What's the period, et cetera, et cetera. So the negative means it's a reflection. Remember, amplitude is never negative. So this is a reflection over x. The amplitude is 3, the absolute value of A. This is a shift down 4. So in proper notation, y equals -4. Okay, so if y equals -4, y represents our cosine. So technically, you should say that the cosine of theta is -4. Okay, so let's look at omega and let's look at phi. Omega is 2. Therefore, the period is 2 pi over 2, which is pi. I think I misspoke. Omega is 2. I'm sorry, I may have said that wrong. All right, so if the period is pi, then my intervals, the period, the length of one cycle from beginning to ending, from start to finish, that's pi. My intervals are going to be pi over 4. Okay, you need to be careful. Many of you are going to say that this is a shift left pi over 3, and that is not correct. This is not a shift left pi over 3 because there's a coefficient on x. So this is where that whole phi over omega comes in. Yeah, that's way too fancy for me. I say 2x plus pi over 3 equals 0. And when you solve for x, you get negative pi over 6. So this is a phase shift left pi over 6. And that's where my graph is going to start if I'm just graphing one cycle, which we're going to do for today. All right, let's take a look. I'm shifting this down, so I'm actually going to draw my sinusoidal up a little bit higher. And we're shifting left. So. I personally always start by drawing in the sinusoidal. So if I'm shifting this down 4 and the amplitude is 3, 12. Okay, I don't have enough room to go by 2, so I'm just going to go by 1s. 1, 2, 3, 4. That was not good planning on my part. So there's my sinusoidal axis. I think I said before, I don't think there's anything such as a cosinusoidal axis, but whatever. Okay, to help you, and I normally do this for myself because after you find all the information and you start graphing, it's very easy to forget that it's a reflection. So a lot of times I'll just kind of draw off to the side to remind myself. It happens to me quite frequently that I graph all this information and everything's great, and then I end up drawing a positive cosine curve. So just a little side note that might help you to put it off to the side. Okay, I start at negative pi over 6. I'm starting at negative pi over 6. Okay. And my intervals are pi over 4. So if I start at negative pi over 6 and my intervals are pi over 4, common denominator there is 12. I'm going to set up my axis, my x-axis, my theta axis to go by 12s. So I'm going to start at negative pi over 6. My intervals are pi over 4. So pi over 4 is 3/12. Pi over 4 is 3/12. 1, 2, 3/12, and that is pi over 12. Another pi over 4, which is 3/12. 1, 2, 12. So that's 4 pi over 12, which is pi over 3. Another 3/12. 1, 2, 3/12. So that is 7 pi over 12. You have to have all of these labeled. Then 3 more 12ths. 1, 2, 3. That's 10/12, which is 5 pi over 6. Intervals are pi over 4, but I started at negative pi over 6. So I needed to find a common denominator, and the common denominator between 4 and 6 was 12. So notice my starting theta interval was negative pi over 6. My ending theta interval was 5 pi over 6 for a total distance. Negative pi over 6 to 5 pi over 6 is 6 pi over 6, and that is pi. So it is a reflection, and I took care of the vertical shift. So now I'm going to take care of my amplitude, which is 3. So this is negative 4. Up 3 is negative 1. Down 3 is negative 7. And then I'm going to connect my points. The graph does not go through the origin. The graph does not go through the origin. Oh, yeah. That is one cycle. And you can put arrows on the end if you want. I'm not going to take off points. This is one cycle. How do you know how much to graph? You read the directions. So if you're asked to graph 2 cycles, so you would start at negative pi over 6. That's where you're starting. I know that the curve goes further to the left, but the starting point is negative pi over 6. If I ask you to graph 2 cycles of the shift, then you would keep going another pi over 6. So this right here represents one cycle, one wave of the shift of the parent function. Now, it's not just a shift. Clearly, this is not just a shift, right? The period has been, the wave has been compressed, the amplitude has been stretched out, but this in general is what I would be looking for. Again, page 423 has all of this information if you feel the need to look in the book instead. And that is phase shifts.